back here, hopefully get something out of this talk. My name's Blair. I'm a lead iOS dev at Martian Craft, and I'm going to be talking today a bit about...
You got an iPod up here.
I do have an iPod.
Is it
Already the technical difficulties. Awesome. So I'm going to be talking about some of the changes that have been made to the localization system and how we can localize our code over the past couple of years. Or, as I may have muttered on the project that inspired this talk, what the hell is Localizable.strings? So, some of you might know that John puts out the calls for papers for this talk in the springtime. I submitted something, kind enough for him to accept it, get me standing up here talking to you folks. And then Dub came around, and this was on the session. And for those of you in the back, or for those of you with just the aged eye for a software developer, 41 minutes, that's longer than 20 minutes. So I'm actually just going to hit play on this and run it at 2x, and I'm going to grab a drink. Seriously. If you've seen this session, you know what I'm talking about. I'll touch on it briefly, but it turned out it was kind of orthogonal for what I was planning on discussing today. So it didn't blow my plans up. I'll touch on it a little bit later, but we're going to talk about the stuff that came before this. So for those of you that have done localization before, you probably know what this is. This is a snapshot from the Xcode project of a localizable.strings file. We've got our English translation, which is the base language for our development in this case. And then we've got translations for Spanish, Vietnamese, and Chinese. Localizable.strings has been the way to do localization on iOS and Apple platforms for a long time. As far back on iOS 10 as I can remember, and I wouldn't be surprised if someone was going to tell me that this was how you did it on next time. That said, Localizable.strings is not without some issues. While it is the standard for localization on Apple systems, it's not an industry standard. So if you're working with an outside localization shop, you would need to find someone that knew the Apple stuff. Additionally, Localizable.strings and how we use it tends to be development language centric. Now, I'm not talking Swift versus Objective-C. For me, I'm talking English. I think for most of us, I'm talking English. For other folks, it could be Spanish or German or French or Portuguese or whatever you prefer. But how we tend to localize our apps in the past has been influenced by how we think in our native tongue. Also, Apple has given us some tools like GenStrings over the years. It's gone through a couple of different actual tools. I think GenStrings is the most current one. These work all right for generating your initial localizable.string. They'll scan your code, they'll give you a file. But they're not great for updating and maintaining your files. So when version 1.1 of your app comes out, you've got 17 new strings and 3 strings that marketing or design ask you to change. You've got to go through all of your strings files and change them manually. And this brings us to another issue. There's some inherent fragility to these files. Technically, .strings is a plist format. I don't know anyone that actually edits them as plists. Most of us open them up as text files and make changes. In older versions of Xcode, we didn't even get compile time safety checked on these. So if you were missing a semicolon, you could blow the UI for one of your translations of the window. Even today, even with Xcode's improved build time support for strings files, they're still very stringly based. Our localization identifiers are still strings. So in your Italian translation, if you accidentally delete a character from a translation identifier, you're going to get, if it's an app that I developed, you're going to get a random English string at a time you don't expect it. And you're not going to catch that unless you're testing your localizations thoroughly. But over the past few years, we've got a couple of enhancements out of Apple that aid in some of these issues. The first one would be, from the code standpoint, that I'm going to talk about, is the introduction of string stick files. These were introduced in Xcode 5 with runtime support for iOS 7 and macOS 10.11. And the first features that these enabled were support for language-specific pluralization rules. Now, it's not uncommon that we've got display stuff in our app that has text and a number. How many of us have written something like this? I have no apples. I have 1 apple. I have 17 apples. I've written this. See a few hands. Thank you for paying attention. One problem. It's wrong. Or at least, it's not necessarily right for other languages. It makes sense for English. But check out Russian. This is the CLDR language pluralization table. This is the entry for Russian. You can see here we've got cardinality rules for 1, few, many, and other. Conversely, for English, we would just have one another. Now look at the rule for one. It's not one, it's 21, it's 31, 41, etc. So if you want to support proper Russian localization in your app, using the sort of technique that I just showed you, you need to learn the Russian rules. And then you also need to turn your code into utter spaghetti, because you need all these if statements for every language you want to support. So, strings dict files to the rescue. This is a strings dict entry for a language pluralization. And what you can see here is top level, I've got a key, which is my localization identifier, labeled as localized description. What you can see under here is I've got a dictionary entry, and it's localized format key. This is the main string that I want to translate. You have translated. And here's the key. Percent, pound, at mark, item pound, at mark. The stuff inside all those symbols, that's a variable name. Item pound is a variable. And then below here, you can see I'm defining the rules for item pound. I'm saying it's a plural rule variable. Because I'm old school, I'm saying the printf formatter is elegant. I'm saying unsigned long. You can probably get away with just using D there. But then here, I've got for English, I have the translations for other 1 and 0. No item, 1 item, however many items. What does that do to my code, my call site? That whole if statement is gone. I have a single caller in this localized string. I look up that key, and then I call string localized string with format. Pass in that format string that we just received, and the count. UIKit, AppKit, know how to map your count number to your strings dict tool. And you may probably notice, or you may notice, that is the exact same NS localized string call you make to pull the string out of a strings file. So your code does not care where you're pulling it from. The second feature that was enabled in support for strings dict file is support for display context-specific strings. These were added in iOS 9 and macOS 10.11. They weren't terribly well publicized though. If you were at WWDC in 2017, the localization session, you may have seen some folks from Apple talking about this feature. The way they were talking about it, I was fairly convinced that it was a new feature for those versions of the OS. Fast forward a few months, Daniel Martin posted this to Twitter, pointing out that this API has actually existed since iOS 9. So it was 2 years older than I thought. That fact blew my mind. But if you saw this tweet, you saw the responses. A lot of the responses indicated that a number of fairly experienced developers didn't even realize that this feature existed at all. So Apple has not done a great job of publicizing it. So how does this work? Well, again, we're going to have our trusty strings dict entry. And again, it's going to be keyed off of our localization identifier. In this case, label.testWith-message. Instead of a variable like I showed you for the pluralization entry, here we've just got a single dictionary NS string variable with rule. We've got 3 numbers here, 10, 25, and 30. And you notice, as the numbers get bigger, the translated string gets longer. So what do those numbers mean? Well, that refers to the number of M units that can fit in your window at the current body size of the size of your current body text. So if you're running on a 12.9-inch iPad Pro in landscape mode, if you've got a full width label that goes this long, and a really tiny label that's only about this long, they're going to have that same M width value because it's the window. So the way I like to think about these is they're kind of like size classes for strings. They exist, there is basically one entry for the current state of the art. If you resize your window, if you rotate, if you go into split screen mode, the current M width value is going to change. It's going to switch strings. Additionally, if you support dynamic type and your users switch their base font size, your M width unit is going to switch. So how does that look? Well, here we've got running in Xcode. You can see I'm displaying testing string. If you remember, that was the value that corresponded to 25. Let's rotate to landscape mode. And UIKit automatically pulls in the newer, longer string. Yeah, this is a string that never ends. How does UIKit decide which string to run? It's kind of like the Price is Right. It picks the biggest number without going over the max. Unlike the Price is Right, you don't have to bid a dollar. If all of your numbers are bigger than the M width count of your screen, UIKit's going to pick the smallest one that it can get. Now, as I said, some of this stuff has traditionally been fairly poorly documented. When Xcode 5 came out, when we got string stick support, Xcode 5 didn't even include a template for these things. So you had to jump through hoops to create a file. We didn't have documentation for dynamic with strings. That got added after Daniel pointed it out. Somebody from Apple went and actually wrote some really thorough documentation on the API method that backs that. If all the documentation is that thorough, it'd be great. But if you go to the localization documentation guide, there's an entry on string stick. That hasn't been updated in a while, because that only has the pluralization rules. It doesn't have information on the display context-specific strings. So unfortunately, you're kind of jumping all over the place to find documentation on all the stuff that's supported. So the second big feature that we've gotten in Xcode over the past couple of years is support for xlif. And this was introduced in Xcode 6. And unlike strings files, xlif is an interchange format. We're not bundling these with our Xcode is capable of exporting them. We send them out to our translators, we get them back. Xcode is capable of importing them. And since this is something you're sending your translators, it's a good thing that this is an industry standard. So any reputable localization shop that you're working with should have tooling and should know how to deal with these things, which is a nice improvement. So how does Xcode go about exporting your xlifs? Well, it can automatically generate your xlif from your code. It looks for your localized string. This means that you no longer need to provide a base language strings file. Hence, the title of the talk. It took me a while to wrap my head around this, but you had to kind of fight Xcode if you wanted a base language strings file at this point. And as a result, strings files go from being something you have to hand edit and hand maintain to just being another resource file that you replace. You know, most of the times we're working with panes, if we're working with audio files or fonts, we don't have to go in and hand edit the bits of them. We replace them whole hog. Now we can do that the same with our strings files because they're machine generated. However, even though this came out in Xcode 6, we didn't get support for xlif didn't gain support for string stick files until Xcode 9. So I hope you can kind of see a trend here, unfortunately, but hopefully Apple's getting better in that regards. As I said, Xcode 9, finally, support for string stick files. And additionally, the pluralization support for string stick files knew the pluralization rules for different languages. So you don't have to do anything special if you write your code in English and want to request that Russian translation. Xcode is capable of exporting that file for you. It knows how to deal with that. It tells your translators what you need. So what does that look like? Well, let's do an xlif export for that first string stick file I showed you. This is for French. You can see here we are requesting the full string. We've got item count in there as the source. And then we've got the rules for item count. We've got entries 4, 0, 1, and other. Now how about Russian? Well, Russian, we've got the same thing where we're asking for the full string with the variable name. But underneath that variable name, we've got the 0, 1, and other rules. But we've also got few and many. Got that for free. Didn't have to learn what Russian language support needed. So that takes good deal of weight off your mind when you're trying to make sure that you're accurately producing resources for people running in these locales. Unfortunately, xlif support for display context-specific strings is not fully there. If you take that display context string dict entry that I showed you with the 10, 25, and 30 rules, if you export that from Xcode, the exported xlif is only going to have a single entry. It's going to say its width is 1, and it's going to be your shortest string. Now you may say, hey, this is XML. I can hand edit this. I can add my 10, 25, and 30. I can send that to my translators. They can give me the 3 different links I need, and then I'll import it. And Xcode imports one entry from that dictionary, and it says that its length is 1. So unfortunately, this is one area where Xcode is actually can be destructive with your resources. So kind of what I suggest doing here is if you're going to use display context with specific strings, create a separate string stick file for them. And in your localized.string call site, use the variant that lets you specify a table name. Point at the specific variable with entry, And then either when you export your xlif or when you're getting ready to import them, pull those out so that Xcode is not overwriting your information. And xlif is XML. As far as XML goes, it's fairly readable. So it's not that hard to find these if you set them up properly. If you put them in a separate strings.dict file, the xlif file will actually have a file entry. So each file that's translated has a file entry. So if you have an XML processing tool of choice, it's not that hard to find the particular entries that you want to remove, pull them out, put them in another file, get rid of them, whatever you need to do. We got one other enhancement over the course of Xcode 9 with support for localization. In 9.3, Apple let us specify a custom prefix for the localized strings calls. So in this scenario, if you've got your own localization system, your own macros, and you decide that you want to opt into xlif generation, you can just set this setting, and Xcode will be able to find your call sites. So if you do decide you want to migrate to this, hopefully you won't have to change a bunch of your code to support it. So what about Xcode 10? Well, the big change in Xcode 10 workflow-wise is that Apple's introducing the concept of a localization bundle. Previously, when you would export your localizations, you would just get the xlif file. Now you get this whole package. There's a notes folder in there where you can put in notes for whatever you want. That's your place to dump stuff. Source contents is the stuff from your app that generated. It's the source for the localization, so that your translators can get more context than just what they can get from the XML file. But everything I've talked about is still valid because there's the xlif file. It's still in there. So Xcode 10 changes are additive. They don't really replace any of the enhancements that have been made over the past few years. So if you're going to adopt an xlif-based workflow, this may have some impact on your code and how you deal with your code. If you're familiar with how Localized String works, there is a multi-step process for it to decide which string it's going to display. So when you make an Localized String call, the first thing it looks for is an entry in a strings file for your current language. If it doesn't find that, it looks for an entry in a strings file for your base language. If it doesn't find that, it looks for a value argument in the call site, and if it doesn't find that, it uses the key value for the call site. However, if we're going with the xlif format, we're getting rid of that base language strings file. So we're losing that potential source of truth. This means that every time UIKit or AppKit is going to display one of your strings, it is going by what's in the call site. And additionally, the call sites determine what ends up in your xlif file when you export from Xcode. So if you're reusing strings in your app, and if you've got slightly different values for each string, that's going to cause a problem because Xcode is going to use the first value it finds. And the concept of first isn't really defined anymore. So what does it look like if you use the same localization key in multiple places with different values? Well, this is the output from doing your export localization on the command line. Hopefully it's not too small so you can see I've got a key localization test string, and it's telling me that it's being used with multiple values. And it's telling me that it is dropping any one after the first one. So unless you're careful, if you're not careful about using your localization strings, you're at risk of having unexpected values show up at unexpected times. So I'm just going to close out with a couple of tips here. In general, if you're fighting the tooling, stop and think about if there might be a better way. I was fighting the tooling to get a localizable.strings file in English for this project that started this idea. And I couldn't figure out why Xcode was fighting me on it. And I had to stop and think and go back and reread the documentation and realize that Apple's recommendations had changed. However, if you do need to fight the tools, if you have a legitimate reason to fight the tools, like for instance, your variable with strings are going to go away, fight the tools there. Don't lose data from your app because the tools have a deficiency. So segregate your variable with strings into their own strings.dict file so that you can easily pull them out of either your requests or of the data you're reading back from your translators. Avoid reusing your localization keys. As I said, we no longer have the backing of the localizable.strings file. So every time you use a localization key in your code, it's going to determine, based on that particular call site, what's displayed in your error. And we can't be sure which one's going to be used as the source for the extra generation. And when you actually, someone decides that you need to change one of your common display strings in your app, if you're using the same localization string over and over and over, and if you're calling it 17 times in your app, you're going to have to change all 17 of those call sites to get a new string. So instead, you probably want to centralize your reuse strings somewhere. Have static locations that you can reference. And there's some tooling around this. I've seen some third-party projects, but unfortunately it seems like they're all expecting to read your source from strings files. I haven't found a good one that will either read it from an XLIF file or will leverage the export localization functionality from Xcode. So that's what I've got for you today. Hopefully you all got something from this, and if there's any questions or if you want to talk about anything, tell me something that I missed, I'll be around. Thank you for coming, and I hope everybody's enjoying the show today.